Okay, so this video is solving systems algebraically, which is basically an algebra 1 review. So the first method is substitution. You pick an equation, you solve for one variable. So basically the goal is to have something like y equals blah, right? X equals blah. Basically, you want a variable that's isolated, okay? So you have to have at least one equation that looks like that. Then you substitute it, right? So plug in, replace, because that's what it means to substitute. And then you're going to solve for the remaining variable, making sure that you understand that there should just be one variable remaining, all right? One type of variable. Plug the number you found into the either equation to get the other half of your solution, and write your answer as an ordered pair, x comma y. Okay, so let's review a little bit, right, of what we're doing here. So there's three possible solutions, right? So the first one is when you have one solution, and that is when you have just any intersecting lines, right? So that would be your x comma y. That is the purpose, or that's like the main goal when you're using any method. The next one would be if you have no solution, right? So no solution means they don't have a common shared point. So when you have a system of equations with two variables, that means that they're parallel lines, right? So when you're solving equations, that basically means that the left side, whatever it may be, will not equal the right side. Okay, and you'll see an example of that. And then the last one would be infinite solutions. Infinite solutions. Okay, so that basically means that you're going to have two lines that are directly on top of each other, right? So they're coincident lines or coincident lines. I'm not sure on how to pronounce it. I know how to spell it, not sure on how to pronounce it. Okay, coincident, coincident, I don't know, I've heard both. Okay. For number one, we can see that we have y equals x plus 2, x plus y equals 8. Okay, so step one, you want to be able to see if you have an isolated variable. Okay, so by isolated, right, remember we have to have y equals blah or x equals blah or whatever variable, right? If we have z, it could be z equals blah. It's not just going to be limited to x and y. So here we can see that this variable right there, right, that y is completely isolated. It's y equals blah, okay? So in the second equation, we see that same y right there. So because those y's are equivalent to each other, because they're the exact same thing, then we can just substitute this part in here. So you're going to have x plus, but instead of y, I'm going to substitute what the expression that my y equals, which is x plus 2, and then that's going to equal 8. Okay, parentheses from here on out, it's just algebra 1. So I'm just going to like walk through it, and I'll just explain as I go for all the examples, right? We have parentheses. This is a positive 1, so I know it's not going to change anything. So we have x plus 2, and that's going to be equal to 8. Again, just algebra 1, solving an equation. X plus x, you have 2x plus 2. That's going to equal 8. We're solving for the variable x. Subtract 2 to both sides. So you're going to have 6. So you have 2x equals 6. The inverse of multiplying is dividing. So you're going to divide both sides by 2. So x is equal to 3. Now remember, our goal, right? Okay. Our goal is to find the solution. And so far, we have found half of it, right? We found this half, x equals 3. So if x equals 3, x is down here, so I'm going to plug that 3 in. You can clearly see that you still have to find another variable. So what do we know so far? We know x equals 3. So from here, you just need to choose one of these equations. It does not matter which one. You're just going to pick one and plug what you know back in. So I'm going to choose y equals x plus 2 because it has my y isolated, and that's exactly what I'm looking for. So I'm just trying to eliminate having to solve for y. If I plug it in the second one, right, I would have to put that 3 in there, and then I would have to use inverse operations to isolate the y, versus the first one, it already has it done for me. So we have y equals, and we know x is 3, so I'm going to plug it in, plus 2. So y equals 3 plus 2, which is 5. So my solution is that the ordered pair 3, 5. Now, don't forget, you should always be checking your work, right? So how would we check that the ordered pair 3, 5 is our actual solution? Well, you would just plug it into the original equations, right? So you know this is x and y. 5 equals 3 plus 2. Well, that's 5 equals 5. So check. Yes, that is true. So I know that is true for the first one. So now you have to check for the second one. So we have 3 plus 5 equals 8. Well, 3 plus 5 is 8. 8 equals 8. Yes, check. This is also true. So because they are both true, I know this equation, or not, I'm sorry, this ordered pair works for both equations. So this is the only solution for both of them. Okay, so yes, our solution is 3, 5. Okay, example 2. For example 2, you would notice that I do not have a variable that's isolated, right? I don't have a y equals blah or an x equals blah. So what you could do, or what you're going to do, is isolate a variable you choose. Remember, it can be x or y. For the first one, I can see that my y has a coefficient of a positive 1. And my y in my second equation also has a coefficient of a positive 1. So it really would not matter which one of these you chose. So I'm just going to do the second one, okay? Because, so to solve this for y, right, I would add 8x to both sides. So we end up with y equals 8x plus 1, okay? So this is the equation that we're actually going to use. So my y is isolated right here now, and this exact same y is right there. So now I can just use substitution and plug it in. So I'm going to use the first equation, so 2x plus, and I'm going to substitute the y in. So y equals 8x plus 1, so I'm going to put 8x plus 1. Always do parentheses for these examples. It just so happens that when I plug it into the parentheses, it doesn't really have an impact, but you will have situations where it does. So better be safe than sorry. So then now we're just going to go on ahead and use algebra 1. Okay, so we're going to have 2x. This is a positive 1 being distributed, and a positive 1 isn't going to change anything. So plus 8x plus 1, that's going to equal 1. Combine my like terms. So 2 plus 8 is 10x plus 1 equals 1. Subtract 1 from both sides. So you're going to get, I did do this right? Yeah. You're going to get 0, which is okay. Oh, wait, hold on. This is supposed to be a 6. I knew something was weird. Okay. Sorry, that's supposed to be a 6 right there. I knew something was wrong. So when you subtract, okay, let me go back and make sure. So I have 2x plus, when I solved for y, I did plus 8, so 8x plus 1. So 2x plus 8x plus 1 equals 6. So then we have 2x, we multiplied, right? Nothing happened. So 2 plus 8 is 10. Bring down my 1, subtract 1, so this would be 5. So we have 10x. Divide both sides by 10, so x equals 1 over 2. So this is your first part of your answer. So then now we're going to plug in. So again, remember, it doesn't really matter which one you choose to plug it into, right? It can be, you could even plug it into this one, right? Because this equation is equivalent to this one. So I'm going to choose the first one. So 2 times 1/2 plus y equals 6. So 2 times 1/2 is 1 plus y equals 6. Subtract 1 to both sides, so y is equal to 5. So your answer here would be y equals 5. So my solution, remember, is an ordered pair, x comma y. My x was 1/2, which you could have plugged it in a long time ago, and then your y is 5. Now remember, to check your answer, right, which I expect you to always do, you would just plug this ordered pair back into the two originals. So you would have 2 times 1/2 plus 5. Does that equal 6? Which it does. And then you would have, for the next one, we have y, which is 5, minus 8 times 1/2. Does that equal 1? Well, 8 times 1/2 is 4, right? Because you're really just cutting 8 in half. 5 minus 4 is 1. So yes, they're both true. So this is my solution to this system of equations. Okay, so that was example 2. Moving on. Example 3. We have y equals 5x plus 13. And then 2y equals, 2y minus 10x equals 12. So for this one, my y is already isolated. So I'm going to substitute that y into the other equation so that I can, pretty much you're making that y invisible. It's still there, right? Because y is equal to this. It's just replaced with something else. So you're going to have 2 times all of this. So you would have 5x plus 13 minus 10x equals 12. Now, this is why I'm telling you to always put it in parentheses, right? Because now you're going to have to apply distributive property. So 2 times 5 is 10x. 2 times 13 is a positive 26. Minus 10x equals 12. So for this scenario, right, combine like terms. So we have a positive 10x and a negative 10x. Well, 10 minus 10 is 0. Then we have plus 26 equals 12. So 0 plus 26, we end up with 26 equals 12. Well, what does that mean? Can the number 26 ever actually equal 12? Well, no, right? They're never going to equal each other because they're two different numbers, which is what we put in the front of our notes, right? So see here, we put if we have a number or the left side of the equal sign does not equal the right side, that means there's no solution, so the lines are parallel. So our answer here would be no solution. For example 4, we have an isolated variable already, which is right there. And we can see that same variable right above it. So all of this is going to get substituted in that y. So you're going to have 2 times, we have 2x plus 3 equals 4x plus 6. Again, we have distributive property, so this is just algebra 1. So we're going to have 4x plus 6 equals 4x plus 6. You should already see something here. If you don't, it's okay. Just keep going, right? So we have variables on both sides and numbers on both sides. So I'm going to go on ahead and subtract my 4x from both sides. So 4 minus 4 is 0. We're going to bring down my 6. 4 minus 4x, again, is 0. And that's going to happen sometimes. You have to not be scared of 0. So we're going to bring down my 6. On this situation or scenario, we ended up with 6 equals 6. Well, what does that mean? 6 equals 6. They're the same, right? So if they're the same, again, in the front, we put, oh, we didn't put that here. So if you have a number, let's go on ahead and add that to our notes in the front. I'm sorry. If you have a number and it equals the other number, then you know they're going to be infinite solutions because the lines are right on top of each other, right? Which you can kind of see that in this step right here. 4x plus 6 is the exact same as 4x plus 6. So these two lines both have a slope of 4 and a y-intercept of 6. So this means that we have infinite solutions. Okay. Method 2, we're going to go on ahead and keep going, even though technically this was day 2. I mean, it's cool. All right, so elimination. So when we eliminate, right, when we eliminate something, it means to get 0, right? So technically you want the number 0, right? If I tell you you have $5, how do you eliminate that? Well, you go and spend the exact same amount, right? So 5. So for this type of method, there was a mini activity that we did in class, right? So just real quick, if you have 5x and negative 5x, what would you do in order to get 0 out of this, right? You have two options. You can either add or you can subtract. Those are your two options. So if you have 5x and you add negative 5x, that's going to give you 0, right? But if you have opposite signs, so let's just go on ahead and fill this in. So what I made kids write is if you have opposite signs, so let's write that over here. If you have opposite signs, then you're going to add, right? But if you have same sign, right, which I referred to as triple S. So if you have same sign, you're gonna subtract, right? You can manipulate an equation to always be able to add. That's up to you, right? But or you can just analyze the set of equations that are given to you, and if you have same sign, triple S, subtract, or if you have opposite signs, you're just gonna add. Okay, so example 5. For this one, so the first thing you need to make sure that your variables are lined up, right? So we have x's on top of each other's, y's on top of each other's, and the numbers, which basically means you want standard form, right? So when you're using elimination, you want ax plus by equals c, ax plus by equals c. That's what you're looking for, which is what we have here. Now, you need to find the ones that match, okay? And when we say match, I just care about the coefficient. The coefficient of this x is 2. The coefficient of that y is 3. This is just a constant, so that doesn't matter. The coefficient of this x is 4, and the coefficient of this y is negative 3. These right here are the ones that match because this is a positive 3 and a negative 3. I don't care about the signs. That's why I made y'all write this right here. Okay, so because these 3y and 3y, they match close enough, I just have to figure out, what am I going to do? Am I going to add or subtract in order to eliminate this variable? I'm choosing this one, which means I'm going to make it go to 0. So if I have opposite signs, I'm going to add. So if you're going to add these two, you have to add everything. So you have to add your x's and you have to add your constants vertically. So 2 plus 4 is 6x. Then we have a positive and a negative, which is 0, which is what I wanted. And then 34 plus negative 4 is going to be a positive 30. So this is elimination method, right? We got rid of the variable we didn't want. So that's 0. It's gone, which leaves me with 6x equals 30. Now we're just going to do algebra 1 and we're going to simplify. So we're going to divide by 6 to both sides. So x is equal to 5. So that's half of your solution, right? Because we're not done. Remember, a solution, right? Our goal is to get an ordered pair x and y. So far we have an x, which is 5. Now, to get our y, it's the same as substitution. You really just plug it back in, okay? So we're gonna plug back in to any equation you want. So I'm gonna choose to use the first one. So 2x plus 3y equals 34. And I'm gonna substitute the 5 in for x. So 2 times 5 plus 3y equals 34, which is 10 plus 3y equals 34. Subtract 10 from both sides. You're gonna end up with 3y equals 24. Divide both sides by 3, so y is equal to 8. So your second half of your solution would be 8 here. Now remember, how do we check, right? So you have a way to check yourself and know that you're doing it right. So you're just gonna plug it back into both equations. So 2 times 5 plus 3 times 8 has to equal 34, yes or no? Then you're gonna have 4 times 5 minus 3 times 8. Is that going to give you -4? Yes or no? And they both need to be true in order for this to be correct. If one of them comes out false, then that means you did something wrong or something happened here. Okay. All right. Next one. Example 6. So same thing. Make sure that your variables line up. X's, Y's, numbers. We're good. Now for this one, you're going to notice that this is a 2 and a 3, those don't match. And this is a 4 and a 3, those don't match. So for this scenario, we're going to manipulate the equations and force them to match. By that, I mean, you're just kind of like a triangle, right? You can multiply it by a scalar, right? And you know that it's similar to the first one and it's increased by, you know, a certain number, but it still doesn't lose its shape. It's still a triangle or whatever. Okay, so something kind of similar to that, right? So here I want to find the least common multiple that I can force them to match. So would I rather match 2 and 3 or 4 and 3? Well, 2 times 3 is 6, right? So but 4 and 3, the least common multiple would be 12. So I'd rather do 6 rather than 12. So we're going to go on ahead and multiply this entire thing. Okay. What's going to give me 6? Well, a 3. And then this bottom one, well, what's going to give me 6? 2. Okay. So I have decided that I'm going to force my x's to match. Okay. So this is going to give me, you're going to multiply. So 3 times 2 is 6x. Then we have 3 times 4, which is a 12y. And we have 3 times 10, which is going to give me -30. Then you're going to do the same thing with the bottom one. 2 times 3 is going to be 6x. 2 times 3 again is going to be a +6y. And then 2 times -3 is going to be a -6. Now, remember, we specifically multiplied them by these numbers because I wanted my x's to match, which they do. Okay, so now we have same sign, right? So when it's same sign, you're gonna do triple S, right? So same sign, subtract. So I'm gonna subtract all 3 of these. 6 minus 6 is 0, which is exactly what we want. Then 12 minus 6 is 6y. And -30 minus -6, right? This turns into a positive. So -30 plus 6 would be a -24. So we have 6y equals -24. Divide both sides by -6. Y is equal to -4. So this is half of your answer. Remember, your solution needs to be an x, comma, y when possible. So your y here is going to be a -4. So now that you have plugged that in, you're going to go and find your x value. So you're going to choose one of the equations, and it really doesn't matter which one, right? So I'm going to choose, so from here, we're going here. Sorry, it's going to look a little wanky. So we have 2x plus 4, but instead of y, we have -4 equals -10. So now you're going to use algebra 1. So 2x plus negative 16 equals negative 10. Add 16 to both sides. You're going to have a positive 6. So 2x. Divide both sides by 2. So x is equal to 3. So here's your next solution, 3, negative 4. Now remember, to check your answer, right, you would plug in. So you're going to have 2 times 3 plus 4 times negative 4. Is that equal to negative 10? Then you're going to have 3 times 3 plus 3 times negative 4. Does that equal negative 3? And they should both be true. So you can check that on your own. Sorry, you guys, someone's here. I'll continue the video. So go to the next video.